Hi, in this video, I'll be solving this problem, which was actually sent to me by a high school student in an honors algebra class. The problem asks to write the equation of this graph, and it doesn't say what kind of graph this is, but looking at the shape and the fact that it has a vertical asymptote, it appears to be a logarithmic equation. So in this video, I'll be solving this problem using algebraic methods. In the next video, I will solve this problem using graph transformation. There will be 3 steps in this video, which you can skip to using the scroll bar on YouTube. In step 1, I'm going to solve this algebraically, but the trick here is instead of writing it as y as a logarithmic function of x, I'll be writing it x as an exponential function of y. Step 2, I will check my answer. Finally, step 3, I do some algebra to switch the equation back into the form of y as a logarithmic function of x. That part obviously is optional because the question asks to write the equation of, and once you have the equation, you're done. You don't need to write it in any particular form because the question is not asking for a particular form. And like I said, in a follow-up video, I will be solving this problem using graph transformation techniques. When I get that ready, I'll put the link above. All right, let's go. This is a logarithmic function of y in x. Y is log function of x. One thing we can do is write a general logarithmic function with the constants are unknown, and then we plug in the x and y. We have like 4 equations where the x and y are all plugged in, but all the constants are unknown, and then we solve for that. But I'm not going to do it that way. I'll do it with x as an exponential function of y because log and exponential functions are inverses of each other. So if y is a log function of x, then that means x is exponential function of y. And the reason why I switched this way is because most of us are a lot better at handling exponential equations than we are at handling logarithmic equation. A general exponential function looks something like this. Y is equal to sum a e to the bx. That would give me an exponential function that has a horizontal asymptote on the x-axis like this. And then if it got shifted up or down, I will change this y into y minus some k as part of graph transformation. Whereas here, I have x as an exponential function of y. So that means I have x is equal to some a e to the b y. But the vertical asymptote, remember that the logarithm function usually has a vertical asymptote on the y-axis. This one has an asymptote that's shifted to the left by 5. So that means we're looking at x plus 5 is equal to a e to the b y. That's my equation. And now I'm going to go look for capital A and little b. Let me copy this picture below, and then we'll start solving. We're here, and we know that the form of the equation will be x plus 5 is equal to a times e to the by. We're given these 4 points. So we're going to plug them all in, and we're going to solve for capital A and B. The first point, 3, 3, gives us the equation 3 plus 5, that's 8, is equal to capital A e to the 3b. The point negative 1, negative 1, negative 1 plus 5 is 4. The third point, negative 3, negative 5. Negative 3 plus 5 is 2. And the last point, negative 4, negative 9. Negative 4 plus 5 is 1. And we're going to solve these equations for capital A and little b. There are two unknowns. Capital A is one unknown, little b is another unknown. So I really only need two equations. So I'm going to pick two of them. I'm going to pick the first two. Why not? Really doesn't matter which two. 8 is equal to A e to the 3b. 4 is equal to A e to the negative b. You can solve by substitution, or you can solve by elimination. I'm going to do both. Let's call this equation store, and let's call this equation store. Using substitution, I can get, it doesn't matter really, but I'm going to use store. I want to do substitution. I want to isolate A, so I can multiply both sides by e to the b. Then e to negative b and e to the b cancel. That gets me A is equal to 4e to the b. And then I substitute that into the first equation, into store. 8 is equal to 4e to the b, e to the 3b. Divide by 4 both sides. I get 2 on this side. And e to the b, e to the 3b. Same base, e to the m times e to the n is equal to e to the m plus n. Same base, multiplication of two exponentials will become an addition in the exponents. So this becomes e to the 4b. And I take ln both sides. Ln of 2 is equal to 4b. B is equal to ln of 2 divided by 4, which is ln of 2 to the 1/4. A is equal to 4 times e to the b. That's from here. That's 4 times e to the ln of 2 to the 1/4. E to the power and log base e, they cancel. Because they're inverses of each other. This is 4 times 2 to the 1/4. A is equal to 4 times the 4th root of 2. Right? That's how you solve A and B using substitution. Now I'm going to do it again, but using elimination. Because I want to introduce you to a method of solving two exponential equations using elimination. Remember when you solve a system of linear equation, something like 3x minus 2y equals 7, 8x plus 2y equals -4, then what you do is you add them side by side so that the minus 2y and the plus 2y cancel. Now let's look at these two exponential equations. In an exponential equation, things are multiplied. So in a linear equation, adding, subtracting are your operations of choice. In an exponential equation, you look at it and you see a bunch of multiplication, you see raised to the power, which is also a form of multiplication, like a super form of multiplication. So multiplying and dividing should be your operations of choice. Therefore, I'll do it like adding equations side by side, except that in this case, instead of adding side by side, I'm going to divide them side by side. 8 is equal to A e to the 3b. 4 equals to A e to negative b. And then I'm going to divide them side by side. The a's cancel. On the left, 8/4 is just 2. On the right, the a's are gone. And I have e to the 3b divided by e to negative b. When dividing two exponentials of the same base, right? They have the same base of e, a to the m divided by a to the n. I subtract the exponents, a to the m minus n. That's the rule. So in this case, that means I'm going to subtract. Be careful here. I'm going to take 3b and I'm going to subtract a negative b, which is actually adding a b. E to the 4b, not 2b, is 4b. On the left, I have 2. 2 is equal to e to the 4b, ln both sides. Ln of 2 is equal to 4b. Divide both sides by 4. I have b is equal to ln of 2 over 4, which is ln of 2 to the 1/4. I got b. I go back to my two equations. I pick one of them, doesn't matter which one. And I plug in b to solve for a. Plug in the star equation. 4 is equal to a e to negative b, which is a e to negative ln 2 to the 1/4. I'm going to rewrite this negative power as a denominator. So remember, if you have a to the negative x, then it becomes a to the x in the denominator. If you have a to negative x in the denominator, it becomes a to the x in the numerator. A divided by e to the ln of 2 to the 1/4. E to the power and ln cancel. So this is just a divided by 2 to the 1/4. I have the equation 4 is equal to a divided by 2 to the 1/4. That gets me a is equal to 4 times 2 to the 1/4, which is 4 times 4th root of 2. My equation is x plus 5 is equal to e to the by. I plug in the b. I'm going to move the plus 5 to the other side. I'm going to subtract 5 both sides. A e to the by minus 5 of x is equal to 4. 4th root of 2 e to the b. B is ln 2 to the 1/4. Y minus 5. Oh, look, there's e to the power and there's ln. They should cancel. Well, the problem is I have an extra b here, so I need to do a small step before I can cancel. I'm going to write this as e to the ln 2 to the 1/4, the whole thing to the power y. Everything else through there. All of this is just 2 to the 1/4. And copy down everything else. These, I can put them together. 2 to the power y over 4 minus 5 and x. Final answer. That's the equation of the graph. Okay. Now that I have found the answer to the equation, I need to check and make sure that it is the correct answer. I have 4 points on the graph. They result in 4 equations. But using just 2 of them, I was able to figure out the equation. So I need to make sure that the rest of the points also fit. So I need to plug in all the x and y and make sure they all work. So let's go ahead and do that. It's always a good idea to check your work. That's my equation. I'm going to check. I have 4 points to check. My function is x in terms of y. So I'm going to put in my y, and then I'm going to calculate my x, which is 4. Radical 4 of 2 times 2 to the y over 4, the whole thing minus 5. For the first point, y is equal to 3. Then x is equal to times 2 to the y, plug in 3, 3/4, minus 5. Fourth root of 2 is the same as 2 to the power 1/4. That's 2 to the 4/4, which is just 2. So it's 4 times 2 minus 5 is equal to 3. Y equals 3, x equals 3. That's good. Next point, y equals negative 1. X equals 4. 2 to the y over 4, that's negative 1 over 4 minus 5. These cancel. Have 4 minus 5, which is equals to negative 1. That's good. Next point, y is equal to negative 5. These together makes 2 to negative 1. 4 times 2 to negative 1 minus is equal to 2 minus 5 equals negative 3. Y equals negative 5, x equals negative 3, correct. And the last point is y equals negative 9, and x supposed to be negative 4. Y equals negative 9. X is equal to 4 times 2 to the 1/4. Negative 9/4. This is 2 to the negative 2. 4 times. This is 4 divided by 4 minus 5. Negative 4. X equals negative 4, y equals negative 9. That's correct. I hope that as you follow my work, you realize that the number on this column is the y number. Nice. That's our final answer. Now, this part is optional. I'm going to rewrite the answer as y as a function of x. This part is optional because the question didn't ask for it. They asked for an equation, and we get an equation. So we're done. But I'm just going to do that just so you see how it's done. I want to isolate y, so I have to start cleaning up things from the outside in. Right, so first there's this minus 5 here away on the outside. I'm going to add it both sides. So I have x plus 5 is equal to 4. Now I'm going to move this by dividing both sides. Cancel. 2 to the y over 4 is equal to x plus 5 divided by 4 times 4th root of 2. All right, now to isolate this, I'm going to undo the 2 to the power by taking log base 2 both sides. So if I have log base 2 here, then the log base 2 and the 2 to the power will cancel. And on this side, also log base 2. Log base 2 is equal to y over 4. And at this point, I can multiply both sides by 4, and I get y equals to 4 times log base 2 of all of this. But what I notice is that here's a 4, that's 2 squared. Here's the fourth root of 2, that's 2 to the 1/4. And on the outside, there's a log base 2. I would like the log base 2 to cancel with these. So I'm going to do some cleaning up before I multiply both sides by 4. Remember that log base a of x over y is equal to log base a of x minus log base a of y. So the left-hand side here is equal to log base 2 of x plus 5 minus log base 2 of the denominator, which I already figured out is 2 squared times 2 to the 1/4. 2 squared times 2 to the 1/4 is, when you have the same base, you add the exponents. So 2 plus 1/4 like that. And 2 plus 1/4 common denominator is 9 over 4. So this is log base 2 of x plus 5 minus base 2 log base 2 of 2 to the 9/4. Log base 2 and 2 to the power cancel. What I have left is just 9 over 4. So this whole left-hand side here is log base 2 of x plus 5 minus 9 over 4. And the right-hand side is equal to y over 4. Now I multiply both sides by 4. I have 4 log base 2 of x plus 5 minus 9 is equal to y. I'm going to write y over here. Box this up. That's the alternative solution to the problem. That's the algebra solution. In the next video, I'll solve this using graph transformation. And when I have the link, it'll be in the description. So watch out for that. Thanks for watching. Subscribe for more contents. Bye.